myself Rohit from third year AML branch, and our course name is Deep Learning Neural Network and Large Language Model. And our assignment one is about implement and compare the performance of CNN and LSTM for sequence-based dataset. And our team members are Rohan Dr, Rohit T, myself, and Rasai G. Kiroji, Shivkumar VC, and our in, submitted to Chaitra A, Assistant Professor of AML Department. Next slide. Introduction. Here, our project is about sentimental analysis, which means finding out whether a piece of text is positive or negative. And it uses AI and deep learning to understand human emotions from text automatically. You are comparing like two deep learning models, like CNN and LSTM are two deep learning models. And here CNN stands for convolution neural network, usually good to recognize pattern. In the LSTM is a long short-term memory, good at understanding sequence like sentences, speeches, and text. Here we are using the IMDb movie review dataset, and the next slide, data collection and pre-processing. In simple words, let's take an example. Take raw. Our first task is about take raw, messy human language and turn into clean, structured format that machine can understand. Here, real text like movie reviews contain slang, punctuations, and different writing styles. And here we clean and format it so that a computer can easily process it. And we started with thousands of movie reviews from the IMDb dataset. And each review was broken down into individual words, and every word was converted into unique number. Here we used a large data set of movie reviews and we splitted each sentence into words. This is called the tokenization process. Here each word was then replaced with a number, like good is 14, bad is 27. So the model can work with the members instead of text. To ensure every review was the same length, so we padded the shorter ones and trimmed the longer ones. Yeah, it means the model needs input of the same size. So if a review was short, you added zeros at the end of the padding. If the movie was too long, you cut it to a fixed size. And this process transformation chaotic text into an organized grid of numbers perfectly prepared for neural network. After cleaning, tokenizing, and padding, the messy text become a neat table of numbers. This is a format that CNN and LSTM can understand and use for training. And the next further slide is explained by my teammate Rohan Dr.
So thank you, Rohit. I'm Rohan Dr. So this is the task 2, implementation of the CNN model. For our second task, we built our first model, a convolutional neural networks or CNN. It means that thinks of the CNN as a keyword spotter. Think of the CNN as keyword spotter. It doesn't read the sentence of deep grammatical structure. It means it quickly looks at the whole review. Third point, instead it scans the entire review and learns to identify small, powerful combinations of words that are strongly indicators of sentiment. It explains it finds only the small groups of words like very good or not bad that shows strong feelings. It's incredibly fast and efficient at finding these emotions hotspot to make final judgment. It explains it doesn't care about the order of the whole sentence. It just spots the keyword. So next slide. So this is the task 3, implementation of LSTM model. Our third task was to build a different kind of model, that is the long short-term memory network or LSTM. The means the it thinks of LSTM as story reader. Instead of the just spotting keyword, it reads the review by word from the beginning to end. It reads the whole review word by starting to finish. It has a memory that allows it to remember the context from earlier in the sentence. It explains it has a memory the what it reads earlier in the sentence. This may helps in understanding things like jokes, sarcasm, sarcasm, or when the meaning of sentence changes in the middle. This is crucial for understanding nouns. Sar, then Nilsala,
Hmm.
sarcasm and sentence where the meaning changes halfway through. So next slide is explained by Sahil.
Thank you, Rohan. And the task 4. It is a task 4. It was a time for the final exam. We enlisted both models on 25,000 new reviews they had never seen before. And the result was, it was almost a draw. Both the CNN and LSTM model scored the top marks with accuracies around 87 to 88%. This tells us that for this particular data set, both strategies are highly effective. The key difference was in the process. The CNN got the right answer quickly by spotting keywords, while the LSTM took its time to read and understand the context before making its decision. So we have a trade-off. Do we want speed or do we want a deeper level of understanding? And in the task 5, hyperparameter tuning and conclusion. Finally, in task 5, we focused on the refinement. This as a tuning a car engine to get the best performance. We tweaked several settings, but one of the most important technique was we used is called dropout. During training, it randomly ignores some neurons. This forces the model to learn more robustly and not really on any single piece of information. It's a powerful way to make the model generalize better to new data. So, in the conclusion, this project shows that there are multiple paths to success. CNN are fast, efficient keyword spotters, while LSTM are deep. Methodologically, readers, the best model choice truly depends upon the specific problem you are trying to solve. Thank you for your time. I am now happy to answer any questions. Thank you. And the code and for the next code part. In the task 1, data collection and pre-processing. Here we are importing all the required libraries like import dumpy, TensorFlow, and the Keras. Here Keras is used to build deep learning model. Here IMDb dataset is a built in movie review dataset for sentiment analysis. A pad sequences helps to make all reviews of equal length. Matplotlib and the classification report are for visualization and evaluation. Here, and the next line, vocab size is equal to 10,000. We only consider the top 10,000 most frequent words. Max length is equal to 250. Each review will be trimmed or padded to 250 words. And in the next line, embedded dim is equal to 128. Each word will be represented by 128 dimensional vector. And the loading the IMDb datasets. The IMDb datasets are automatically downloaded from the TensorFlow. It contains maximum 25,000 training and 25,000 movie reviews. Each review is already converted into a list of integers, and each number represents a word, padding the sequences. Since reviews have different lengths, we pad them so all have the same size. Padding post means zeros are added at the end, and the reviews of it are shorter. And for the output, uh, a shape of the training data is 25,250. The data was successfully downloaded and processed. Training data shape 25,250. Here, 25,000 are the reviews. Each length was 250. Testing data shape 25,000 comma 250. Same for the testing set. This confirms our data is now ready and to be used for the deep learning model. Here we loaded the IMDb dataset for the sentiment analysis, which contains 50,000 movie reviews. We limited our vocabulary to the top 10,000 words and padded each review to a length of 250 words to make all input uniform. The output confirms that our training and testing sets each have 25,000 reviews for model training. And for the task 2, implement CNN model for sentiment classification. And here in the first line, we are building a conventional neural network to classify IMDb movie reviews as a positive or negative. Here and in the next line, embedded layers, which converts each word into a 120 dimensional dense vector. A Convo 1D layer scans through the sequence and detects local patterns in words like a common phrase. And in the next line, global max pool link ID takes the most important features from each filter, reducing the data size. And in the next line, dense 64, which is one of the hidden layer that helps the model learn complex relationships. And in the next line, dense 1 activation, the output layer that gives a value between 0 and 1, or 0 for negative and 1 for positive sentiment. The next line is compelling the model. Adam is the optimizer that helps the model learn efficiently. The binary cross entropy is used for because it's a binary classification problem. We also track accuracy during training. And the last part is model output. This table shows the structure of the CNN model. It lists each layer type and how the data process begin. The parameters are not showed here yet because the model hasn't been fully built with the data. We train the model up for 10 epochs. A batch size of 64 means and 64 reviews are processed at a time. Validation split is 0.2 means 20% of training data is used to check performance after each epoch. Early stopping stops training automatically when the model stops improving to avoid overfitting. And for the last for the output, epoch 1, a model starts with 68% accuracy and quickly improves to 88% on validation data. Epoch 2 and 3, training accuracy increases rapidly to 98 to 99%, while the validation across accuracy stabilizes around 90%. This means our CNN model is well trained and performing with around 90% accuracy on unseen reviews. Here we built a CNN model to classify movie reviews as positive or negative. The embedded layer converts words into vectors. The Convo ID layer captures improvement word patterns, and the dense layer performs the classification. After training, our model reaches a which shows that it can correctly identify most review sentiments.
Yeah,
And in the task 3, implement a LSTM for sentiment classification. The LSTM model to classify IMDb reviews as a positive or negative. A embedded layer converts each word into 128 dimensional vector, helps the model understand meaning. And the LSTM layer reads the review word by word and remembers the most important things like context. And then 64 hidden layer that processes data featured, compelling the model. We use Adam Optimizer to help the model learn efficiently. We track accuracy to measure model performances. Output. This table is the layer used in the LSTM model. It indicates that the model hasn't been built yet because it depends upon input data. Once data is passed, once data is passed, the model structure becomes active and ready to train the LSTM model. We train the model for up to 10 epochs with batch of 64. Early stopping stops training automatically when no more improvement happens. And for the output, epoch 1, the model start learning and slowly with the and gives about 53% of accuracy. Epoch 4 and 5 accuracy improves and significantly and the model learns from the data. Epoch 7, the model achieves about 94% training accuracy and 86% validation accuracy. And it here in the task 3, it implemented a LSTM model for sentimental analysis, unlike CNN, which dropout helps prevent. And at the last, we tuned the LSTM model using the dropout early stopping to reduce overfitting. The accuracy improved moderately, and the graph show a more balanced training process. Thank you. Thank you. Thank you.